There are 4 factors that affect the rate of reaction, and we've talked about these before. So temperature, surface area, concentration, and catalysts. We're just going to go through each one individually. For temperature, we know that as temperature increases, the particles move faster, which means we would have more collisions per second. It would also mean that the colliding particles, more of them would have the necessary activation, meaning that we would result in more successful collisions. A good rule of thumb is that an increase of 10 degrees doubles the reaction rate. Not always going to hold true, but it's a good rule of thumb. If we're looking at the graphs, if we're looking at concentration versus time, at a lower temperature, we'd have less steep of a curve, and then higher temperature, our curve becomes steeper. And then we've seen our Maxwell-Boltzmann graphs diagrams before, and what this shows is that we've got more particles that have the activation energy or higher at a higher temperature. The second factor that affects rates of reaction is surface area. So in a solid substance, only the particles on the surface can come in contact with the surrounding reactant. If the solid was in powdered form, the surface area effectively increases, meaning that the rate would increase. If we're looking at concentration versus time then, for something that has less surface area, the curve's going to be less steep. More surface area, the curve's going to have a greater, it's going to be more steep. The third one, concentration, we've seen that this already affects the rate of reaction. If we're talking about it just in terms of a factor, the more concentrated the reactants, the more collisions there will be per second per unit volume. If we're looking at our concentration versus time graphs then, the lower concentration would have the lower graph, higher concentration would have a steeper graph. The last one we need to talk about in a little bit more detail are catalysts. Catalysts increase the rate of a reaction by decreasing the activation energy of the reaction. Basically, they change the mechanism by which the process occurs. They don't get used up in the reaction. And some catalysts can also make the atoms line up in the correct orientation so that they enhance the reaction rate. If we're looking at a reaction pathway diagram, the uncatalyzed reaction is going to have a certain amount of activation energy, which would be here. You can see for the catalyzed reaction that that activation energy has been decreased. In terms of the Maxwell-Boltzmann distribution curves for a catalyst lowers the activation energy. So that means more particles will possess the lowered activation energy. Therefore, the rate effectively increases. If we're looking at our distribution curve then, without a catalyst, we're going to have an activation energy that's higher. With a catalyst, the activation energy is lower. So the area under the curve, or the number of molecules that possess that activation energy with a catalyst, is greater than without a catalyst. Finally, it's worth knowing that there are 2 types of catalysts. There's homogeneous and heterogeneous. A homogeneous catalyst is one that is in the same phase as the substances reacting. For example, if we have a reaction that's all in the liquid state, then the catalyst that's homogeneous would also be liquid. For a heterogeneous catalyst, we have 2 phases. So the catalyst is in a different phase than the reaction. So for example, If our reaction is taking place in a liquid, then a heterogeneous catalyst would be, say for example, a solid.